In this example, I want to give an explanation for why we should believe proposition 4, which says that if the terms in the sequence are non-negative, so we're always adding at least something 0 or larger, so the partial sums in the sequence are non-decreasing, and if in addition all the partial sums are bounded, then in fact the series has to reach a limit. So it's a property of the real numbers that if you have an increasing sequence that is bounded, then it has to have a least upper bound. It has to have a number so that these sequence of terms approaches that number. You can think of it in a number of different ways. You can say that they aren't holes in the real numbers, so if these things are creeping towards something, they have to actually reach it. You can say that the real numbers just have this least upper bound property, that every bounded sequence has a least upper bound. Or you can think of it as the real numbers being connected. You can't take this part and that part and have a gap in between them. One way or the other, it's a property of real numbers that if we have an increasing sequence of real numbers, they have to approach something. And so what that means is that we only care about the partial sums being bounded or not when the terms in the sequence are positive. So if from some point on we know that the partial sums are bounded, then the sequence converges.